Hello everyone. Today we are going to discuss another problem, and this problem is basically based on decision tree algorithms and their functioning, because these two topics like entropy and purity are solely related to uh, attributes in the used in splitting of the particular node into two branches. So we will be discussing that in some later video, but let's focus. So compute the entropy and purity of the confusion matrix shown in the table below. So we are given a confusion matrix for these clusters, cluster 1, 2 and 3, and we are given all these 1, 2, 3, 4, 5, 6, 7, sorry 6 attributes, and we need to find the entropy and purity of the confusion matrix. So for that we must first understand what is entropy. So entropy is nothing but uncertainty or randomness in data, as you might have already guessed it, and purity is a little bit mathematical. So it is the number of correctly matched classes and cluster labels, that is each class will be associated with a cluster label, and that is divided by number of data points. So this gives a idea of what purity is. Like it resembles it's mostly the opposite of entropy, but in some different manner. It's more standardized. So let for calculating entropy we will have to use some standard notations, as you can find in literature. So first, Pij is probability that a member of cluster I belongs to class J, right? So cluster I, that is 1, belongs to, suppose, finance. So what is the probability? Now Mi is the number of objects in cluster I. So for each cluster I have just calculated the total and put it on the right side of the table. And then L means number of classes. So since there are 6 classes, so it is 6. K is the number of clusters, which is 3. Then we have M is equal to number of data points. So we need to calculate like all of them. Either we can sum the row total, or we can sum the column total. Same thing will happen. So the total is 3204. Now EI, remember the notation is important. EI is the entropy of each cluster, means each cluster will have its individual entropy value, and then by using that we will calculate the total entropy of the confusion matrix. So the formula for calculating Pij is Mij by Mi. As we have discussed, Mij is the number of objects in class J in cluster I, and Mi is the total number of objects in cluster I. So that we can simply basically calculate it using the table. Then Ei is, this formula is important. So this formula is quite important, and one thing which you will note is there is a minus sign in this entropy value, right? So which will actually make the entire value positive. So Pij log base 2 Pij, and this will be calculated for all the classes. Then the total entropy is Mi by M into Ei. So first we need to make the Pij matrix in order to calculate the entropy. So for that, let's have the clusters first written down. Then all this I have written, and what is written here is 1 by 693. So you'll see here that there is one data object of cluster I that belongs to class entertainment out of 693 elements of the cluster 1, right? So this basically this probability is what is talked about here. So that we will write similarly for all the values, just divided by the total. Similarly for cluster 2 and cluster 3. After that we will start calculating the entropy of cluster 1. So minus sign is outside, and then we will put, like, since there are 3 ones here, so I've just put in a single basically term, and then 11, 4 and 676. This we will calculate and then finally the entropy comes out to be 0.2. Next, for the second cluster, again we will have the same thing, like we will just calculate using these values, right? Just the exact same way we did for E1. Similarly, we'll calculate. Remember, there is a minus sign outside, so we'll get it as 1.1. Then E3. Similarly, we will get 1.691. Now we need to calculate the total entropy of the confusion matrix, which is equal to, this is the number of objects in cluster 1 divided by the total number of data points into entropy of E1, right? And this is the total data points. And similarly we will do for all. This is the number of data points in cluster 2, number of data points in cluster 3, and these are the entropies respectively. So we'll calculate, and this comes out to be the total entropy of the confusion matrix. Now we'll go for purity. So purity, if we check, Pi is the purity of cluster I, and the overall purity of confusion matrix is Mi by M into Pi. Mi is the same notation we used for entropy, so don't get confused, and M is the total number of the basically objects in that particular class. I hope, yeah, it is the total number of data points we have, M, and Mi is the number of objects in cluster I, right? So if we just check here, it is, we need to calculate the max of Pij. So if we see P1, the maximum of them is, let's check, you see that this is the maximum, right? Out of all these, this is the maximum out of all the basically classes in cluster 1. Similarly, this is the maximum, and in this is the maximum. So with this all, we'll take them, and finally what we'll do, purity as number of objects in C1 by total number of objects. Again same for C2, and right, and we will multiply the Pi we calculated for each of the clusters, and then we'll just do the math, and this will be the answer for purity. So I hope you understood what I tried to explain. Thank you.